Hello, this is Dr. Mode, and this is going to be a BCA method stoichiometry practice problem. This question is going to be split into two parts. The first part involves balancing a chemical reaction. So here's the first part of the question. Larry burned some ammonia. Write the balanced chemical equation. Nitrogen trihydride reacted with oxygen gas to produce nitrogen dioxide and water. Here I'm using the covalent naming system for ammonia, which is nitrogen trihydride. So ammonia is NH3, oxygen gas is O2, nitrogen dioxide is NO2, and water, of course, is H2O. So we need to put this in a chemical equation and balance it. This one is a little bit trickier to balance, so we are going to use the accounting method to balance here. So the initial count for each element is listed here. So what we see is the nitrogen is balanced on both sides at 1, but the hydrogen is 3 on one side and 2 on the other. So to correct that, we need to put the coefficients of 2 and 3 in front of the ammonia and water respectively. And that changes the coefficients to this. So now the hydrogens are balanced, but we are unbalanced for the nitrogens. So we have to put a 2 in front of the NO2, and that changes the number of nitrogens to 2 on both sides. So now we are going to worry about the oxygens. So what we have on the right side of the reactions, the products, is 7 oxygen atoms. But we can only have an even number of oxygen atoms on the left side. So we're gonna deal with this in this fashion. So to get 7 oxygen atoms, I'd have to put a coefficient of 3.5 in front of the O2. But I can't do a 3.5. The coefficients out in front can only be whole numbers. So what I have to do is cancel those out and double each number to get whole numbers. So now I have my set of coefficients. So here they are in the balanced chemical equation. The coefficients are 4, 7, 4, and 6. The second part of the question is where we get into the stoichiometry. It says, if he reacted 60 grams of nitrogen trihydride, ammonia, with 180 grams of oxygen, how much of each product in grams was produced? What is the limiting reagent and what is in excess? And how much excess reactant was there? And it also instructs you to use the BCA method. So let's pull out the relevant information that we need from this problem. So we have our balanced chemical equation that we did in the previous part. So what we need is we have 60 grams of ammonia, and we are given 180 grams of oxygen. And we're asked how much of each product would be produced. So those are question marks in grams underneath both of those. The other piece of information we need is the molar masses of each of the reactants and products. So here they are. You're going to have to calculate those on your own from the periodic table. Okay, so now we're going to start the BCA method. So remember, the BCA method is a table, and each entry in the table is going to be a number in moles. The B stands for the amount in moles of either the reactant or the product in before the reaction. The C stands for the change during the reaction, so we're going to put a positive or a negative sign in front of each number to indicate how it's changing during the reaction. And the A is after the reaction, the number of moles left over after the reaction. So we know that initially, before the reaction starts, no product has been made. So we can enter 0 moles for both products. To get the number of moles of ammonia, what we do is we take the 60 grams given and we divide by the molar mass to find that we have 3.529 moles of ammonia. We do the same thing for oxygen, where we'll take 180 grams divided by 32 grams per mole, its molar mass, to find that we have 5.625 moles of oxygen. So again, I can't just look at these numbers and instantly know which one is the limiting reagent and which one is an excess. So I'm just going to pick one. So I'm going to pick the ammonia. So if I assume that the ammonia is the limiting reagent, and I want to calculate how much oxygen gas would be required to fully consume the amount of ammonia that we have at the beginning of the reaction, I need to use the coefficients in the balanced chemical equation to do this. So I'm going to need to multiply by the 7, which comes from in front of the oxygen, divided by the 4, where the 4 comes from the number in front of the NH3, to find the number of moles of oxygen gas required that would need to be consumed in this reaction. Well, the problem is I don't have that much. So I happen to choose the wrong one. I only have 5.6 moles, and I need 6.1, almost 6.2 moles of oxygen gas. So I chose the wrong limiting reagent. So we're going to have to start this again using the oxygen as our limiting reagent. Okay, so now we're going to use the oxygen. So I'm going to first calculate how much water would be produced in moles. So again, I'm using the coefficients in the balanced chemical equation, the 6 in front of the water and the 7 in front of the O2. So if I multiply the 5.625 by 6 over 7, I can find that 4.821 moles of water is produced in this reaction. So now for the other product, I'm going to have to use the coefficients in front of the NO2 and the O2, which is 4 over 7, to find that there are 3.214 moles of nitrogen dioxide produced in this reaction. Then I can calculate how much ammonia is required to fully react with the oxygen. So again, I'm using the coefficients in front of the balanced chemical equation, in front of the reactants. So the 4 over 7, and that is going to give me a number here. 3.214 moles is going to be consumed in this reaction. And finally, since the oxygen is my limiting reagent, I'm going to use all of it, and it's gonna be fully consumed. So that is going to leave me with 0 moles of oxygen left over at the end of the reaction. I can subtract the two numbers in the ammonia column to find that I have 0.315 moles of ammonia left over at the end of the reaction. And then for the products, I just bring those numbers down. That's how much is produced in the reaction: 3.2 moles of nitrogen dioxide and 4.8 moles of water. So I can now answer one of the questions. What is the limiting reagent and what is an excess? This is obvious now. The reactant that is completely consumed, there's none left over at the end of the reaction, is the limiting reagent. The one where there is some left over at the end of the reaction, the ammonia, is in excess. So the next question that I can ask is, how much excess reactant was there? So this is a question that is implying that they want the answer in grams. So what I need to do is take the amount in moles left over of the ammonia and convert it to grams. This is simple by just multiplying the number 0.315 moles by the molar mass, which is 17 grams per mole, to find that 5.36 grams of ammonia is in excess. And finally, my last question is, how much of each product in grams was produced? So from my BCA table, I can look at the number of moles that was produced of each product, and I can convert those to grams using the molar mass. So I'll start with the 3.214 moles of nitrogen dioxide, multiply by its molar mass to find that 147.8 grams of nitrogen dioxide was produced in this reaction, and then I can use the 4.821 moles of water that's produced, multiply by its molar mass, which is 18 grams per mole, to find that 86.78 grams of water is produced in this reaction. I hope this helps you out. Thanks for watching.